Okay, this is your 30-second to 1-minute update. So we kind of got everything a little bit cleaned up. We've had time to do some shuffling around and get things squared away because we're getting ready to put the roof on this place. So we got to get all this junk out of here. So right now, this is what we came up with. Okay, so the blue barrels here are going to be chained together to the white barrel. The blue barrels are the ones that we're going to go get the ocean water from Scripps Institute, filtered ocean water. Bring them back, connect them at the bottom, and they'll gravity feed the source tank. The source tank has got an ozone generator, I'll show you in a minute, and UV light on it. Then it umbilical cords up to the power supply. There's 2 more of these modules that need to be built. Okay, so this is just part 1, and then everything is just going to go in this road case, so we can transport it or protect it from the weather because we're outside, obviously. And I got a nice little toolbox that looks laboratory and medical, I guess. And I'm a mechanic. I'm tired of looking at black, red, and blue toolboxes. So this one's pretty cool from Lowe's. Anyway, we got new pumps and new components because we ran out. We got thermal runaway. We're producing way too much heat in the fusion process, which is the ultimate goal. Okay, we're producing fusion, neutronic fusion. Okay, the idea is to make it as hot as possible with the littlest amount of input of power. So I'll put it in the video description. The best that we've done with neutronic fusion is 1/10 of a watt input power and 44,000 BTUs output power. So I'd like to ask you a question. Board members of Proton Spin Technology, they know the answer. What's the difference between somebody who's a genius and somebody who's delusional? I was smart enough to turn on the camera and document my work. Okay, so it come with just 2 electrodes, barely in the water, barely turned on. Can't control this 3,500 watt. 3,500 BTU. I'm sorry. BTU converted to watts. This is a 3,500 watt chiller. Okay, condenser. It's having trouble keeping up. And we're only putting in no more than 1,000 watts. No, 500 watts a channel. And the steam energy is overrunning 3,500 watt condenser. So we had to get a bigger chiller. Well, that helped out quite a bit. Okay, no problem. That basically balanced things out somewhat. But we still have a problem with thermal runaway. So I picked up these 2 oversized igloo coolers from Lowe's, obviously. Because I like Lowe's. I don't like Home Depot. And I like blue, not orange. Except for that. That's laboratory orange. Okay, so this is how it's going to work. It's going to come out of the chiller and then split equally into both containers. We'll be able to put the lid back on this one on the left because I can poke holes in the side for the wort chiller. This one, we're going to cut a hole in the lid so the lid sits down really nice. Then they're going to draw out of the bottom. I'm going to chain these 2 together and plumb them so they are common up to the chiller. So this one will have a different temperature perspective than this one. And I want that because I want this one really, really, really cold because we found out something. If it's really cold, any excess steam coming out of the top gets drawn down by the obvious spectral, the specific gravity of things. Then It's a little funky, but it's just a filter cover. We decided to put a filter bag before the tank, so that the source, so that the condensate water is as clean as possible. We had a little problem. You see here? I got to clean that. I will. That's what happens when you don't have the electrodes hot enough. We're still in test mode, so we can't get the electrodes hot enough. We got some components coming. I'll show you that in a minute. But it makes chlorine gas and it eats the stainless steel. So that's preventable, but that's what happens. But from there, it's okay, because it's coming hermetically sealed into this line over here into the filter press. So ultimately what will happen is this line will go all the way downstairs, and this filter press will be downstairs with the bottling line. That's all in crates right now because we need to keep it clean for the construction. And then it'll have a pre-filter, but if the bag filter is 1 micron over there, this is 1 micron filter, but we don't want to lose any of this graphene. So I want it in the bag filter, and that'll keep this secondary pre-filter, which is at 1 micron, cleaner. Then it goes through the filter press, and it goes to 0.465 micron on the first pass. On the first pass, this one here. And then this one is 0.2 micron. And then it leaves a carbon block filter. Then we got more of these food safe beer kegs, or soda kegs. They're actually soda kegs. People use them for beer, but they're actually soda kegs with these really tight quick connects that are hermetically sealed, okay, from the Cornelius Company or Firestone, the people that supply Coca-Cola. So then we can, the product water that's finished goes in another cartboard, but I have it disconnected right now because I'll show you. You saw me starting with the glass cartboards because we got really sick people that don't really care, okay? They don't really care if it's exactly perfect. We're just trying the best we can. It's water, and people have drank worse water and lived, okay? So now it comes to the cartboy here, and I can use this wand to gravity feed like you saw in the other videos, okay? It just like the winemakers do to start out, in the beer makers. Nothing rocket science here, but I'm just explaining that we're just doing the best we can. So instead of those plastic fittings on the drums over there, they're going to get upgraded to the stainless steel fittings, so that I can disconnect the drums and take them with me by turning off the petcock and the source water petcock. And then the source water will continue on to the pump. Okay? And so in case you missed it, because I didn't explain it, it's going to replace these two plastic things. That Murphy's Law. Warning. Murphy's Law. Okay? You know exactly what's going to happen to those in plastic. And then I'm going to lose all my water. And you know what happens when I lose my water. Okay? It's not pretty. Okay. Then it comes over to this pump. And this is the trick thing. I got to kind of say something. This is a process patent. Okay? So all of the components of the patent that are liquid is a circuit. Liquid, steam, electricity, and sound and plasma all engineer in the exact same way of flowing electrons. So if you want to engineer electrical circuit, you can engineer it like a water circuit and vice versa. I'll explain power balance looping and all that cool shit later. It's not important. But what's important is circuits are copyrighted. I'm on YouTube, global copyright as the moment. Okay, so this is apropos to the moment. This, I had to use a ball check valve, really trick stepper motor ball valve that rotates, and when the power goes off, it's got spring loaded, so it's shut, so it's a constant safety feature. Because we had a problem with the reactors just overflowing because the other kind of valve that we used, like this here, well, apparently they failed, and the diaphragm ones just don't work for some reason. It's because they need back pressure. And these pumps that were used for the water, they don't have any back pressure. They're just transfer pumps. So it didn't shut off the diaphragm. So this goes on the shelf for another project. Maybe I'll use it to water my lawn or some shit. I don't know. But that's an essential part of this process patent. Believe it or not. Okay. Anyway. We're trying to get it as organized as possible in an R&D situation. Bear in mind the outside. But there's something cool about being outside that I learned from farming and packaging citrus and lemons. Sometimes it's better to be outside than it is to be in a moldy environment inside with no air circulation. So that's why downstairs in the clean room, it was very important to have air circulation to keep everything fresh. And so this kind of blows away any exhaust and hydrogen that can come out of the reactor that can be reactive. But as you all know, we're moving forward into a nice facility. But we have to get this R&D figured out first. So we got components that we need to put installed before we can fire this back up. Okay, gentlemen and ladies, it's late. Thank you for your time and your consideration, and here's your update.